Good day and welcome to KayTutors. At KayTutors, we demystify your curiosity and we help you to enjoy maths. In the previous class, we learned about negative numbers. We said that negative numbers are numbers that have negative signs before them. Furthermore, we looked at addition and subtraction of negative numbers. We multiplied negative and positive numbers. We explored different examples, real-life examples of negative and positive numbers. And finally, we explained what problems involving negative and positive numbers. So, if you are yet to watch that video, kindly do that because we demystified negative and positive numbers. In today's class, we are going to be learning about approximation. So let's go into the class and demystify this concept. But before we do this, if you are yet subscribed to our channel, kindly subscribe to our channel and turn on the notification bell so that whenever we drop exciting video or educational videos like this, you will be the first to be notified. Okay, so quickly, let's go and demystify this concept. Now, the question is, what is approximation? When we talk about approximation can also be referred to as rounding, when you are rounding a number, okay, to the nearest possible number. So in this case, approximation simply means the value or the quantity. You can as well say the number that is nearly. Take note of the word nearly. Okay, take note of the word nearly, but not exactly. Okay, nearly, but not exactly the same as the original number. Assuming 99 is the original number here. Okay, let's assume that 99 is the original number. Now, when we round these to the nearest tens, our answer will definitely be 100. Okay, so 99 is nearly very close to 100, but it is not 100. 100 is close to 99, but 100 is not 99. That is the simple definition or simple explanation of approximation. Okay, the approximated number is close to the original number, but it is not exactly that number. Okay, so once again, if you are yet to subscribe to this channel, kindly do that. That is the only way you can support us so that we can support other children out there. So who is this video meant for? This video is meant for primary students and secondary students. This video is also meant for parents looking for simpler ways to help their children excel in their homework and in class. This video is also meant for educators looking for simpler method to demystify pupils' curiosity in approximation. So quickly, let us continue our class. Now, whenever you are approximating numbers, you carry out judgment on a particular number. We're going to reveal this very soon. Now, whenever the number you're carrying out your judgment on falls between 0 and 4, that is, if the number is 0, 1, 2, 3, and 4, you round down. And what do you round down to? You round down to 0. Okay, now if the number falls within 5, 6, 7, 8, and 9, what do? You round up. And what do you round up to? You round up to 1. Okay, so let me repeat myself again because we are going to be using this scale of judgments throughout our lesson today. If the number is 0, 1, 2, 3, or 4, what do you do again? You round down to 0. But if the number that you're carrying your judgment on is either 5, 6, 7, 8, and 9, what do? You round up to 1. So quickly, let us look at the scope of our lesson today. By the end of this lesson, you are expected to approximate whole numbers. Okay, so you are expected to round off numbers to the nearest 10, 100, thousand, tens of thousands, hundreds of thousands, and even 1 million. We are going to be approximating decimal figures. And under approximating decimal figures, we are going to be rounding decimals to the nearest whole numbers. Also, we are going to be rounding decimal to the nearest decimal places. And next, we are going to be correcting to significant figures. Okay, so for significant figures, we are going to find significant figures involving whole numbers. We are going to find significant figures involving decimals. We are also going to find significant figures involving decimal figures and whole numbers. The class is interesting. So if you are yet to subscribe, kindly subscribe. Press the notification bell so that whenever we drop exciting videos like this, you'll be the first to be notified. So let's go on and approximate whole numbers to the nearest tens, hundreds, and thousands. Now, example 1. Let's round 74 to the nearest tens. Okay, so if you are rounding to the nearest 10, mind you, you are expected to take cognizance of the number of zeros you have here. Okay, so how many zeros do we have in a 10? We have just 1 0. So you are going to ring the unit number. And what is the unit number here? 4. So since we've ringed this one, we are carrying out our judgment on 4. Now, back to our charts from the first slide. Are we rounding down or rounding up? Of course, we are rounding down because 4 is not up to 5. And since 4 is not up to 5, you round down to 0. And this 0 you've rounded down to, you're going to add the 0 to the number next to 4. Okay, the number next to 4, that is, you are going back from right to left. And you add that 0 to 7. And what will you eventually get? You will get 7. Right? So how many zeros has a 10? It has just 1 0. So we have rounded or approximated 74 to 70. You can now see that what this approximated figure here is very close to 74, but it is not 74. So that is the approximated value. So let us move on to example 2. Once again, how many 0 has a 10? It has just 1 0. So you ring the unit digits here. After ringing the unit digits here, you carry out your judgment on 9. Now, after carrying out my judgment on 9, I know that 9 is greater than 5. Since 9 is greater than 5, I'll round up to 1. And this 1 that I've rounded up to, what should I do with the 1? I'll add the 1 to 8 here. So 1 plus 8, of course, it's 9. How many zeros has a 10? It has just 1 0, so I'll add my 0 here. So 90 is the approximated number of 89. 90 is very close to 89, but it is not 89. So let's move on to the next number. This number is quite tricky, but we are going to deal with it. Yes, I said it. We are going to deal with it. Now, how many zeros has a 10? It has just 1 0. So I'll ring this number here and I'll write my answer. I'll just write 0 here so I won't get myself confused. Now, this number now that I'm carrying my judgment on, is it greater than 5? Of course, it is greater than 5. So I'll round up to 1 and add this 1 not just to 9, okay, but I'm adding it to what? To 99. You understand that now? I'm rounding I'm adding it to 99. So I'll now come somewhere here and say 9 plus 1. 9 plus 1 is 10. I'll write down my 0 and carry 1. Now 9 plus 1 again is 10. So I'll write this, my 100 here. Already I have a 10 has 1 0. So I've already written my 0 down here. So I have 100. So I have rounded 999 to 1000. So the approximated value here is 1000. And of course, 1000 is very close to 999. But is it 999? Of course, it is not. So let us move on to the next number. So this is quite much, but we are rounding to the nearest 100. Now let's take cognizance of the number of zeros here. How many zeros do you have here? You have 2 zeros. So I'm rounding these 2 numbers here. So just as a start, I'll write my 2 zeros here. Okay, because 100 has 2 zeros. Now look at this number. The last number here before the unit number. Okay, if you are rounding to the nearest 100, you are not carrying your judgment on the unit place. Instead, you are carrying your judgment on the tens place. So 8 here is greater than 5, right? So I'll round up to 1 and I'll add my 1 to 7 here. Or better still, I'm adding it to everything here. So 5, 6, and 7 plus 1. What will my answer be? It will be 8, 6, and 5. So what's my answer now? My answer is 5, 6, 8. Okay, so this is 56,800. 56,000 is the approximated value of 56,787. And the last number here, we are rounding to the nearest 1,000. Can you try this? Okay, so let's try this and drop our answer in the comment section. I will move to the next subtopic, and that is approximating decimal figures. Now let's approximate to the nearest whole number. Okay, so before we start, we know that what decimal numbers, for instance, we have 12.67. This is a decimal number and it has 2 parts. We have the decimal part. This is the decimal part, and the whole number part. This is the whole number part. So we've been asked to round up to the nearest whole number. We are rounding off to the nearest whole number. So it means we are throwing this 67 away, not 67. 12.67. We are throwing the 7 away. So in order to do that, we are expected to carry out our judgment here on the 10th place. So since we are carrying out our judgment on the 10th place, 6 is greater than 5, right? And since 6 is greater than 5 or 6 is greater than 4, you round up to 1 and add your number here. You add the 1 here. So what's my answer here? My answer is 13 because 1 plus 12 is 13. You see, I have rounded off to the nearest whole number and I have ignored the decimal point and the decimal numbers. So let us look at other example. Let's round off 29.78 to the nearest whole number. Here, what's our 10th digit here? The number immediately after the decimal point is the 10th digit. You carry out your judgment on the 10th digit, and 7 here is greater than 4. So you round up to 1 and add 1 to the number before the decimal point. So 29 plus 1, what will my answer be? 30. So it's very important that you give your reason, which is to the nearest whole number. Okay, so this is to the nearest whole number. Okay, so let us look at the next example, and that is 616.48. Again, you are carrying out your judgment on the 10th digit, and that is 4. So in this case, 4 is not up to 5. What are we expected to do? Of course, we are expected to round down. So you round down to 0, right? And this 0 you add to the number before the decimal point, not after the decimal point, but before the decimal point. And if I add 0 to 616, or you add the 0 to the whole number, so since I'm adding the 0 to the whole number, what's my whole number here? My whole number is 616. So I have 616 here. So my answer here is to the nearest whole number. 616 to the nearest whole number. Now the last one here, number 3 here is 800. Round 800.51 to the nearest whole number. So again, we are carrying out our judgment on the tens place. And what is the number on the tens place there? This is 5. And since 5 is 5, of course, you round up to 1, right? So you round up to 1. So this will be plus 1, right? And this one that you have rounded up to, you are adding it to 800 here. And what will be your answer? 801 to the nearest whole number. Okay. So next, we are going to be rounding to the nearest decimal places. Before we start this, let us know what decimal places means. Okay, so decimal place, let's say for instance, we have 12 again, 0.678 and 9. So we have, after our decimal point, how many digits do we have after our decimal point? We have 1, 2, 3, 4. So this number now has been written to the nearest 4 decimal places. Why? Because it has 4 digits after the decimal point. Okay, so if I want to round up to the nearest tenth, that is to the nearest 1 dp, this is to the nearest tenth, rounding to the nearest tenth, or rounding to the nearest hundredth, that is 2 dp's, or rounding to the nearest thousands, that is 3 dp's, or rounding to the nearest tens of thousands, that is 4 dp's. What are you expected to do? If you are rounding to the nearest tenth or to the nearest 1 dp, you are expected to carry out your judgment rather, on the number immediately after the 1 dp. You are expected to carry out your judgment on the second decimal place. So if I'm rounding to the nearest 4 dp's, I'm expected to carry out my judgment on the 5th decimal place. If I'm rounding the nearest 5 decimal places, I'm expected to carry out my judgment on the 6th decimal place. And that's how the progression continues. Okay, so let us solve some example. So round the following decimal numbers to the nearest decimal places in front of them. The first one here is round 29.78983 to the nearest 3 decimal place. So since I am rounding to the nearest 3 decimal places, what am I expected to do? I'm expected to count 1, 2, and 3. Then I'll carry out my judgment on the 4th decimal place. Now ask myself again the intelligent question. Is 8 greater than 4? Yes, 8 is greater than 4. And since 8 is greater than 4, what am I expected to do? Round up or down? Of course, I am rounding up. to what? To plus 1. I'll add my 1 to this digit here. So if I'm adding 1 to 9, what will that become? 10. I'll write down my 0 and carry my 1. 1 plus 8 is 9. Then I'll bring down my 7.29. So what's my answer now? My answer is 29.79 and 0. Let us look at another example again. Here we have 616.483 You're rounding this number to the nearest 4 decimal places. So let's count the decimal places here. We have 1, 2, 3, and 4. So our judgment will be on the 5th digit. Okay, so let's ask ourselves again the intelligent question. Is 5 greater than 4? Yes. Since 5 is greater than 4, I'll round up to 1, then add my 1 to the number before the 5. Okay, so if I add 1 to 5 here, to 4 here rather, what will I get? I'll get 5. So I'll have my 5 here. Don't forget to bring down your 3 and your 8, 4. Don't forget to bring down your decimal point, 6, 1, and 6. So what's my answer here? My answer is 616.483 and then 5. Okay, so the last example there, you've been asked to round to the nearest 1 decimal place. You've been asked to round to the nearest 1 decimal place there. So since you've been asked to round to the nearest 1 decimal place, your judgment is where? This is 1 decimal place. Where are you carrying out your judgment on? I want to see your answer again in the comment section. Thank you very much. So let's move on to correcting to significant figures. This is very simple. I love this aspect very well, but it is quite confusing. So let's solve this. So significant figures involving whole numbers. Now, you have to consider something when rounding significant figures in whole numbers. So whenever you are doing this, you are expected to what? The highest digits are considered first. Let's take, for instance, I have 2, 7, 3, and 4. 2 is considered first because it is the biggest digit there. Of course, it's 1,000. 7 is considered next. 3 is considered after 7. Then 4 is considered last. Okay, and other digits are replaced with a 0. Okay, so let's look at some example now. Round the following. Okay, so let's round this. 5,467,345. We've been asked to round to the nearest 4 significant figures. Well, I'm considering this first, second, third, and fourth. So my judgment again is on the 5th digit. Then the rest I'll replace with a 0. So this is rounding down because it is not up to 5. And since I'm rounding it down, it will be 0. I'll add my 0 to 7 here. That is not changed. Okay, so my answer here is what? 5, 4, 6, and 7. 1, 2, 3, 4. 4 significant figures here. And I'll replace the rest with a 0. 1, 2, and 3. I have replaced this with a 0. So how many significant figures have I changed this to? I've changed this to 4 significant figures. Let us look at the next number. Here we have 924,800 865. We have been asked to round to two significant figures. We have been asked to round to two significant figures. So we have 1 and 2 here. Okay, our judgment is on 4. We'll carry out our judgment on 4 while the rest numbers here are replaced with a 0. Remember our rule, right? So let's write. So we have 9 here and we have 2 here. Because 4 is not up to 5, so I am rounding down to 0. Then I'll add my 0 to this number. So what will I get? I will get 9, 2. I'll replace the rest here with 0. So I have 0, 0, 0, and 0. So this is my approximated number to the nearest two significant figures. I've been asked to round to the nearest 4 significant figures. Okay, so here I have 1, 2, 3, and 4. My judgment is on the 5th. So you've seen the pattern, right? If you ask me to round to the nearest 2 significant figures, my judgment will be on the 3rd number. If I am asked to round to the nearest 7 significant figures, my judgment will be on the 8th number, right? So let's continue. So since I've been asked to round to the nearest 4 significant figures, here I have 5, 7, 0, 0. So this is 57,002,861. So my judgment is on 2. I'll round 2 down. Since I'm rounding 2 down, this will be 0. I add my 0 to this 0. This is unchanged. Whenever you add 0 to any number, the 0 remains unchanged. Okay, so I'm rounding to the nearest 4 significant figures, and that will give me 5, 7, 0, 0. How many numbers do I have there? I have 4 digits. I'll replace the digits with zeros. So what's my answer now? My answer is simply 57 million, rounded to the nearest 4 significant figures. Let's round significant figures involving decimals. So the digits of the whole numbers are considered first. The digits of the whole numbers are considered first. Let's take, for instance, we have 547.392. 5 here is considered first. 4 is considered next. 7 is considered next. So you see the digits of the whole numbers are being considered first before we consider the decimal numbers. So let's look at this example. Let's round 546.735 to the nearest 4 significant figures. Again, we have 1, 2, 3, then 4. My judgment is on 3. So since 3 is less than, I'll round down to 0 and add my answer to 7. So my answer here will be 546.7. You replace this with zeros, but zeros after the decimal point standing alone are insignificant, so you can as well just throw that away. So this is 4 significant figures. So we've been asked to round to the nearest 3 significant figures. So since we've been asked to round to the nearest 3 significant figures, what are we expected to do here? We're expected to count first 1, 2, and 3, and our judgment will be on the 4th digit here, and that's the 10th place. Okay, so having done that now, you are rounding up because 8 is greater than 5, and you plus 1 to 4. What will my answer be there? I'll have 925 points. Replace the others with zeros. But since the zeros after your decimal points are insignificant, you can as well choose to leave that. So we have 3 significant figures. So we have successfully rounded 924.865 to the nearest 3 significant figures. So the next one is very simple. I expect you to solve this and drop your answer in the comment section. So let's correct significant figures involving decimal figures with zeros at the beginning. Okay, so whenever you have something like this, what are you expected to do? The zeros beginning the numbers are not considered. Let's take, for instance, we have 0.003 and 4. These zeros are not considered significant. So in order to write in significant figures, you start considering these numbers, but these zeros are not considered. So let us look at some examples now. We have the first one here. We have 0.026897. Owing to the fact that these zeros are not considered, okay, so we'll start counting from here. 1 and 2. Then we'll carry out our judgment here. 8 is greater than 5, so I'll add my 1 to the number next to 8. So what's my answer here? My answer is 0.027, and this is 2 significant figures. Let's look at the next number. So we have 0.002538. We have been asked to round to the nearest 3 significant figures. Just like you are aware, 0 zeros here, these are not considered. So you start counting your significant figures from this number. So we have 1, 2, and 3. So you carry out your judgment on the 4th digit here. Okay, so this is rounding down to 0. And since that is rounding down to 0, you add your 0 here, and what will be your answer? You have 0.0025 and 8. So that is what? 3 significant figures. And finally, we have 0.002586. We've been asked to round to the nearest 4 significant figures. We've been asked to round to the nearest 4 significant figures. And since the zeros are not considered, okay, so start counting from here. 1, 2, 3, and 4, and you carry out your judgment on the 5th significant figures. You round up to 1 and you add your 1 to the next number to 8. So what will my answer be? Don't forget to include your zeros beginning the number. So we have 4 zeros there: 2, 5, 8, and 7. How many significant figures do I have there? I have 4 significant figures. And finally, we've been asked to round this number 0.0002845 to the nearest 2 significant figures. Don't forget that you are not expected to consider the 0 beginning this decimal number. So what are you expected to do here? I expect you to solve this and comment on the comment section. So what have we learned today? We have learned that numbers that are being approximated are not exactly as the original numbers. Instead, they are very close to the original number. We also rounded whole numbers to the nearest tens, 100, 1,000. We rounded decimal numbers to the nearest whole number. We rounded decimal numbers to the nearest decimal places. We also rounded decimals to significant figures. We rounded whole numbers to significant figures. Thank you for watching our video. If you have any question, you can drop your question in the comment section and we are going to be swift with answering it. Don't forget to like, to share, and to subscribe to our channel. Thank you very much for watching. Have a wonderful day and bye for now.